Hello and welcome to the first part of the last set of notes for this unit for precalculus. The last thing that we're going to talk about with these trigonometric functions is how to solve equations involving them. So the first thing I want you to do is, along with me here, just graph. Hold on, this pen's not working. Let me see if I can get this going here. Try this again. There we go. All right, so graph this with me. So we're going to graph the sine curve here, and you're going to notice it only goes between 0 and 2 pi. So the first point is 0, 0. Remember, sine starts at 0, 0. And within the sine graph, remember, it goes up to 1, down to 0, down to -1, and up to, back up to 0. Now, there's a couple other points that I want to put in here. If you notice, this is 90 degrees, pi over 2. So at 30, I want you to put a point at 0.5. And then I also want you to put one right here, one to the left of here, which, if you remember, 90, this is going to be 120, and that's 150. Put a point here and here. Just fill in this graph a little bit. It's going to help us with this first question. Okay, so here's one period of the sine graph. Okay, we talked about this last unit, graphing these things. Now, if I wanted to find the solutions to the equation sine of x equals 1/2, what I'm going to do is figure out sine of what angle is 1/2. Well, you probably noticed that there's actually two spots where the sine of the angle is 1/2. One of them is 30 degrees. And the other one, so this is 30 right here, and the other one's actually right up here, which is 30 less than 180, which is 150 degrees. Okay. Now, -1/2 are here and here, but those aren't what it's asking for. So what I want you to recognize is that these are the two quadrants where sine is positive, okay, in the first and the second quadrant. All right? Now, there is an alternate way of finding this. If I know that sine of x equals 1/2, you can type in your calculator second sine, or sine -1 of 1/2. And what you'll get is 30. Okay, so the answer for this is actually just 30 degrees, but you have to remember that sine is positive in two quadrants. So in quadrant 1, it's 30. But where else is sine positive? Well, sine's also positive in quadrant 2. If you remember A, S, T, C, these are the two quadrants where sine is positive. So 30 in quadrant 2, remember, the reference angle means that it's 180 minus 30, which is 150 for that one. So that's an alternate way, and this is actually the way that we're going to be going about doing it. Now, don't worry about this negative infinity to infinity part. We're going to deal with that some other time. Okay, so let's jump in. So hopefully this will make a little bit more sense when you see an example. So if you look at this first example, we are told to solve this equation. We're told 5 cos x plus square root of 2 equals 3 cos x. And we're going to change this to say, let's not solve it in that, let's just solve it between 0 and 2 pi, or 0 and 360. So just like we did in this original one. So in order to solve this, what you want to do is think of cos x, the whole thing, as a single variable. Okay, so think of this as 5, oops, that is the highlighter. Think of this as 5x plus square root of 2 equals 3x. Well, if it said that, then we just combine like terms, right? So we would write, you can either subtract 5x from both sides or subtract 3x from both sides. I'll do it this way. So I have 2x equals, and then I'll subtract square root of 2 over here, equals negative square root of 2. And then x equals negative square root of 2 over 2. Now remember, this was not x. We just replaced that. That was actually cos of x. I just changed it to x temporarily just to make it easier to see kind of what we're doing. So cos of x equals negative square root of 2 over 2. So if I want to figure out what the angle is, we do the same thing we did up top. I can do second cos of negative square root of 2 over 2. Okay? But don't put the negative in because we just want a reference angle. So do second cos of square root of 2 over 2 and see what you get. So in my graphing calculator, I will do that right now. If I can find my graphing calculator. Here it is. So second cos square root of 2 over 2, making sure I'm in degrees, and you get 45. Okay? So that's my reference angle. So now let's think about what my answers are for what quadrants this angle has to be in. So where, remember, the original one was negative. So which two quadrants is cos negative in? Well, thinking about our ASTC, cos is positive here and here. So we want to put 45 in quadrant 2 and quadrant 3. Those will be my two answers. So in quadrant 2, you subtract it from 180. So 180 minus 45 is 135. So there's my first answer. And then for quadrant 3, you add it to 180. 180 plus 45 is 225. So those are your two answers. Notice, most of these are going to have two answers. All right? Now this is going to be a little different from your answer key because I'm only making you find them between 0 and 360. So just keep that in mind as well. Okay, so there you go. Between 0 and 360 for the next one. So let's do that one now. So same idea. What you want to do is think of each of the tan x's, or tan thetas, as an x. Okay, so you want to solve this just to get that by itself. If it makes it easier, just change it to an x so that you can kind of see the process that we're doing here. Okay, so we want to move this negative 3x over to the other side by adding it, which we get 6x, right? And we want to subtract 2 radical 3, so we get equals 6 radical 3. Last step, divide by 6, so you get x equals, these cancel, square root of 3. Okay, that's a positive square root of 3. Now remember, that wasn't x though, that was tan of theta, right? We just changed it to x to make it a little simpler for ourselves. So we want to know, okay, so tan of theta is square root of 3. There's going to be two answers. So what we want to think about is, okay, well, tan is positive in which two quadrants? Well, tan is positive here and here. So quadrant 1 and quadrant 1 and quadrant 3. So let's find the reference angle. So what we're going to do is write second tan of square root of 3 and see what we get. So second tan square root of 3, and I'm just doing this right in my calculator, you get 60. So we want to put that into quadrant 1 and quadrant 3. Well, quadrant 1's easy. That's just 60. To put it in quadrant 3, what do you add it to? Well, you have to add it to the 180, right? So to put it in quadrant 3 is 180 plus 60 is 240. So there's my two answers. All right, so solving these, you isolate the expression. Basically, you get the tan of theta, you combine them, and then you get it by itself on one side of the equation. And the easy way to think about that is just think of the whole thing as the variable x and then put it back in. So let's do one more. Okay, so here, I've got cosecant alpha minus 6 over 4 equals negative 1. Now, instead of changing that to x, I'm going to do this without changing it to x and see if you guys can follow here. If you can't, you can change it to x and then put cosecant back in at the end. That's fine. So first thing we want to do is think about, okay, I want to get and this is going to be 0 to 2 pi. I want to get that cosecant by itself on one side of the equation, just like I would with an x. So what do I do to both sides? Well, first thing I do is I multiply both sides by 4. That'll get rid of this. So I have cosecant alpha minus 6 equals negative 4. And then I have to add 6. So cosecant alpha equals 2. So there's my final equation that I can do second for. But remember, there is no cosecant in the calculator. I cannot do second cosecant, or the inverse of cosecant. But what I can do is remember that cosecant is the inverse of sine. So if cosecant of alpha equals 2, then sine of alpha equals 1/2. Now I can figure out my reference angle. So I can do second sine of 1/2, and let's see what I get. Second sine, and you should be doing this in your calculator as well, of 1/2, you get 30. So there's my reference angle, right? Now, where is sine positive? So we got to put it in those two quadrants. Well, sine is positive in the first and the second quadrant. First quadrant's 30. And to put it in the second quadrant, you subtract from 180, which is 150. And you'll notice that's actually the very first example that we did up top. Okay? Same exact thing, second sine of 1/2. All right? All right, number 4. Okay, secant. And again, I am going to try to do this without plugging the x in, because it actually does simplify things a little bit. So just remember, these are just like a variable. So think about it as 7x equals x minus 4 square root of 3. Well, what I need to do is subtract this over to combine it with the other side. Right? So that's going to be 6 secant y equals negative 4 square root of 3. And then you divide by 6. So these reduce to 2 and 3. So it'll be secant y equals negative 2 square root of 3 over 3. All right? So if I want to find that, what I first need to do is remember that I can't plug in second secant, but what I can do is flip this. So I can plug in second cos of that. So if I want to do that, then I do second cos of negative 3 over 2 square root of 3. And don't worry about rationalizing that denominator right now. You could if you want to, but plugging it in the calculator will be fine. So second cos of that. And again, don't do negative for this step. I shouldn't have written that. And the reason is because all we want is a reference angle here. So second cos of 3 over 2 square root of 3. And I'm using the Wabbit Emu app that I posted on the page. For an Android phone, there's also a Calculator X for the iPhone that you can use for this, is 30. Okay, so there's the reference angle, which is 30. So when we don't use the negatives, it's going to give us a nice reference angle. So where is, now that remember cos was originally negative, so where is cos negative? Well, cos is positive in 1 and 4, so it's negative in 2 and 3. So I want to put 30 in quadrant 2 and quadrant 3. Well, quadrant 2, we have 180 minus 30, which is 150. Quadrant 3, we have 180 plus 30, which is 210. So there's my two answers for that. All right, we have one more to do today, and please let me know if you have any questions. This last number 5, and we will continue this exact same page with number 6. starting next Monday. So just hold on to this. We're just doing 1 through 5 today. So number 5, same idea. Think of tan A as the x. Oops, that should be tan A. So we have to subtract tan A from both sides. So we have 2 tan A equals -2. Divide by 2. Tan A equals -1. So I want to figure out where tan of A, what angle equals -1? Well, first find a reference angle. Remember, don't put -1 in, put 1 in. And the reason is because we're just finding a reference angle, and then we'll put it in the appropriate quadrant to make it negative. So second tan of 1 is 45. So there's our reference angle. But we want to put that where tan is negative. So where is tan negative? Well, tan is positive here and here, so it's negative in 2 and 4. So 2 and 4. So in 2 is 180 minus 45, which is 135. And then 4, we actually haven't done 4 yet, is 360 minus 45. You always move it from whatever's in the x-axis. 360 minus 45 is 315. So there's my 2 answers. So I want you to try a couple of the homework problems. A couple of good ones would be, let's take a look right here. One through 4. Number 1 through 4 would be good ones to try to make sure you got this. Use the key as a reference. Okay, so let me know if you have any questions, and we will continue this on Monday. And if you haven't turned in that last problem set, please do so. Bye-bye.